This is video number 3 for the checkpoint quiz out of section 11.8. Problem number 4. The resultant of a 25-pound force and another force has magnitude 18.8 pounds at an angle with respect to the 25-pound force of 34.2 degrees. So that means that the angle between the resultant and the 25-pound force is 34.2 degrees. We want to find the magnitude of the unknown force and the angle it makes with respect to the resultant. In problems of this type, you want to align the known force along the x-axis. So if this represents my 25-pound force and the resultant is 18.8 pounds, it would be up here in the first quadrant at an angle of 34.2 degrees. That would make the unknown force right here in the second quadrant, and let's call that unknown force V. Because if I complete my parallelogram and add vectors tailed ahead, there's that unknown force V, and the resultant would go from the origin across that diagonal. The vector equation says that the resultant vector R is equal to the force vector F plus the unknown force V. There's our vector equation. Since we've oriented the force F along the x-axis, its component form is pretty easy. The component form of F would be 25, 0. Now, to find the component form of our vector R, the resultant vector, remember that the vector can always be represented by the magnitude of that vector times the cosine of the angle it makes, comma the sine of the angle it makes. The resultant vector would be 18.8 times the cosine of 34.2 degrees, comma the sine of 34.2 degrees. There's the resultant, and here's the known vector F. Let the components of vector V be V1, comma V2. The vector equation tells us that 18.8 times the cosine of 34.2 degrees, comma 18.8 times the sine of 34.2 degrees is equal to 25, 0 plus V1, V2. And to solve an equation like that, we want to equate the components. The horizontal components gives us 18.8 times the cosine of 34.2 degrees is equal to 25 plus V1. And the vertical components says that 18.8 times the sine of 34.2 degrees is equal to 0 plus V2. Solve for V1 and V2. We get that V1 is 18.8 cosine of 34.2 degrees minus 25. And we get V2 is 18.8 times the sine of 34.2 degrees. And if we compute each of those as decimals, we get V1 is negative 9.5 and V2 is 10.6. The component form of our unknown vector V is negative 9.5, 10.6. Now the next step in order to answer the question is to find the magnitude and direction. The magnitude of V is equal to the square root of negative 9.5 squared plus 10.6 squared. Take each of these components. Take 18.8 times the cosine of 34.2 minus 25 and square that value, and then take 18.8 times the sine of 34.2 and square that value, and add those components together and take the square root of the result. It tells us that the magnitude of V is approximately 14.2 pounds. Next, the direction angle. This is our coordinate system. V is in the second quadrant, and we want to find the angle it makes with respect to the positive x-axis. If I call that angle alpha, then I know that the tangent of alpha is 10.6 divided by negative 9.5. That means that alpha is the arctangent of 10.6 divided by negative 9.5. And you have to remember that the range of the arctangent is between negative pi halves and positive pi halves. And then we're going to have to adjust it for the situation that we're given. And when you compute the value of that arctangent, you end up with negative 48.1 degrees, which is really down in the fourth quadrant. the corresponding angle between the negative x-axis and our vector v is 48.1. Therefore, the direction angle is 180 minus 48.1 degrees. The angle that the vector v makes with respect to the positive x-axis. And computing 180 minus 48.1 gives us 131.9 degrees. Vector v, the magnitude of vector v is 14.2 times the cosine of 131.9, comma, the sine of 131.9. But the question said we wanted to find the angle v makes with respect to the resultant. We know that, draw that diagram. This is the vector f, the resultant r, and the vector v. We know that the angle v makes was 131.9 degrees, and the angle r makes with respect to f was 34.2 degrees. 131.9 minus 34.2, we end up with the angle between the vector v and the resultant is 97.7 degrees. Angle vector v makes with respect to the resultant vector is 97.7 degrees, and the magnitude of vector v is 14.2 pounds.